Running circuits from different electrical panels within the same electrical metallic tubing, or EMT conduit, is generally not permitted by electrical codes, including the National Electrical Code, or NEC. There are several important reasons for this prohibition, primarily related to safety and the potential for creating ground loops or other undesirable conditions. Firstly, the purpose of an equipment grounding conductor, or EG, is to provide a low impedance path for fault current to return to the source, which is the electrical panel. When circuits from different panels share the same EMT, the ground fault current path becomes complex and can compromise the effectiveness of the grounding system. Each panel has its own grounding electrode system connected to earth. If you combine circuits from different panels in the same conduit, you are essentially connecting the grounding systems of those panels together through the metal conduit. This can create a ground loop, where current circulates between the grounding systems of the two panels. Ground loops can cause several problems, including increased electromagnetic interference, or EMI, unwanted current flow in the grounding conductors, and potentially elevated voltage on the equipment grounding system. Secondly, the NEC requires that the equipment grounding conductor be run with the circuit conductors. This ensures that the impedance of the ground fault current path is minimized. When circuits from different panels share the same EMT, it can be difficult to ensure that the equipment grounding conductor for each circuit is properly routed with its respective circuit conductors. This can increase the impedance of the ground fault current path and reduce the effectiveness of the grounding system. Thirdly, in the event of a ground fault, the fault current needs to be able to quickly trip the overcurrent protective device, such as a circuit breaker or fuse, in the panel supplying the circuit. When circuits from different panels share the same EMT, the fault current path can become complex and unpredictable. This can delay the tripping of the overcurrent protective device, increasing the risk of electrical shock or fire. Fourthly, another concern is related to voltage drop in circuit performance. Circuits from different panels may have different voltage levels or be serving different types of loads. Combining these circuits in the same conduit can lead to imbalances in the current flow and potentially affect the performance of the circuits. Fifthly, consider the implications for future troubleshooting and maintenance. If circuits from different panels are intermingled in the same conduit, it can be difficult to identify and isolate problems. This can increase the time and cost required to perform maintenance and repairs. The NEC provides specific requirements for the installation of electrical circuits, including the separation of circuits from different sources. These requirements are intended to ensure the safety and reliability of the electrical system. While there might be some limited exceptions under very specific conditions, such as control circuits for equipment with multiple power sources, the general rule is that circuits from different panels should not share the same EMT conduit. It is crucial to consult the latest edition of the NEC and local electrical codes to ensure compliance. If you have a situation where you need to run multiple circuits in the same area, consider these compliant alternatives. Firstly, use separate EMT conduits for each panel's circuits. This provides a dedicated and isolated path for each circuit, minimizing the risk of ground loops and ensuring proper grounding. Secondly, use a multi-compartment raceway. These raceways are designed to physically separate circuits from different sources within the same enclosure. Thirdly, use cable assemblies with separate grounding conductors for each circuit. This allows you to run multiple circuits in the same area while maintaining proper grounding and separation. Remember that proper grounding is essential for electrical safety. A properly grounded system provides a low impedance path for fault current to return to the source, minimizing the risk of electrical shock and fire. Always consult with a qualified electrician to ensure that your electrical system is installed and maintained in accordance with the NEC and local electrical codes. Improperly installed or maintained electrical systems can be dangerous and can create a significant risk of electrical shock, fire, and equipment damage. Ensure that all electrical work is performed by qualified professionals who are familiar with the latest codes and best practices. Consider these points when dealing with electrical installations. Firstly, always de-energize circuits before working on them. Use a voltage tester to verify that the circuit is de-energized. Secondly, wear appropriate personal protective equipment, or PPE, such as gloves and safety glasses. Thirdly, follow all applicable codes and standards. Fourthly, never work on electrical equipment when you are tired or distracted. Fifthly, if you are unsure about something, ask for help from a qualified electrician. Electrical safety is paramount. Always prioritize safety when working with electricity. If you are not comfortable working with electricity, hire a qualified electrician to do the work for you. Remember that electricity can be dangerous, and it is important to take precautions to protect yourself and others. The NEC provides detailed requirements for the installation of electrical systems. These requirements are based on years of experience and research, and they are designed to ensure the safety of people and property. It is important to be familiar with the NEC and to follow its requirements when installing or maintaining electrical systems. If you have any questions about the NEC, consult with a qualified electrician or electrical inspector. They can provide you with the information you need to ensure that your electrical system is safe and compliant. Also, be aware of local electrical codes. Local codes may be more stringent than the NEC, and it is important to comply with both. Local codes are typically enforced by local electrical inspectors. These inspectors can provide you with information about local code requirements and can inspect your electrical system to ensure that it is compliant. In summary, while sharing EMT between different panels might seem like a shortcut, it introduces significant safety and code compliance issues. The potential for ground loops, compromised grounding paths, and difficulty in troubleshooting make it a practice to be avoided. Always prioritize safety and adhere to the NEC and local electrical codes to ensure a safe and reliable electrical system.